Hi, this video is going to continue our exploration of redirections, but this time we're going to talk about another type of redirection that allow us to not necessarily overwrite the files that exist, if we specify the name of a file that exists, but keep appending to the end of that file. So that can be very useful if you keep running a certain tool or a certain program, or a program even that you wrote yourself, right, on your system, and you want to use a file to act as a log file, for example, all the error message that your program is outputting on std_err. So a scenario like this one would require you to either redirect, every time you redirect std_r to a file, to redirect it to a new file. And maybe the name of the file would have a name that contains a timestamp or something like that to show when that file was generated. But most of the time when you generate log files, what you want to do instead is have one log file, generally at a preset location for your system, and you want to output into that file error messages, for example, log messages, and you want to output them with a timestamp at the beginning of the line and then the error message. So that allows you to keep all of your log, all of your output at the same in the same file, right? And if you stop your process, your program, if you restart it later, well, this the output for the new session, the new work session, is going to go naturally at the end of the file and append to the output of the previous work session. So let's take a look at how we could do this. Well, we have been using so far these symbols for redirecting any sort of output. Okay. So now we still want to redirect output. So this is our command. Okay, this is std_out, this is std_err, this is std_in. So we still want to redirect one of the two output, but we know that those tools here, the syntax, the specific syntax, mean that we are going to overwrite the content of the file. That's what we have been doing in the previous videos, right? So instead, we want an alternative syntax to append. Okay, and that's easy. We just double the greater than sign. So for example, instead of saying I want to redirect in overwrite mode my std_out, I can say I want to redirect in append mode my std_out, just by using two greater than instead of one. Obviously, the syntax is going to work also with the over notation, and this will enable me to also append a redirection from std_err. Okay, so it's just a little change in the syntax and a little change in the behavior of the underlying redirection. So let's try this out. We have our sort. Let's try with std_err first. Okay, so we have our sort-l that creates a mistake here, an error. So we know how to redirect this to sort.err. Okay, and then we can look at sort.err. Oops, and sort.err contains our message. And if I keep using like this, you know, sort a bunch of time and redirect to sort.err, what we expect to see here is sort.err is going to contain the message only one time. So it's going to contain pretty much the output of the last time I used sort. It's going to contain the std_r output of the last time I used sort out of this bunch of times that I use sort. So it's not proper for, you know, logging. So we're going to try our new syntax instead. So let me double this greater than sign. Okay, used it one time. Sort.err. Let's see what's in there. Well, the sort.err file already existed, okay, from my previous experimentation. So you can see already that it's working. I already appended to the end of that file. If I use sort.l a bunch of time, okay, sort-l, sorry, and I cat the content of sort.err, you see it has been removed. If I erase sort.err, okay, the same way that the previous type of redirection created the file if it didn't exist, well, this type of redirection still does that for us. So if I just do this, okay, and I do cat sort.err, alright, you can see that the file was previously erased. So when I did my redirection, my double redirection there, my append redirection, you can notice that the file was created from me and that the content of the file is obviously the first message. And if I keep doing this, the file already exists, so there's no need to recreate it or anything. I just keep adding the messages to the file, append the message to the file. Okay. So it's working with errors. Let's just see in a very quick, simple example here. If it's working with a standard output. So I'm going to change a little the example here. Echo hello world, and then I'm going to redirect it to echo.out. Okay. Alright, so the file echo.out appeared. I'm going to erase every other sort file that we had in the way. Cat echo.out hello world. Okay, everything's normal so far. So let's try again now. Double redirection. So the file right now, let me double check. The file exists, so I'm going to erase it first, okay? And I'm going to try my double redirection. There we go. Echo hello world 1 greater than echo.out. So the file was created. Echo.out contains hello world. Okay, nothing special there. But if I keep doing this, and then I take a look at cat echo.out, it is appended instead of re-return. Last little test to be completely thorough, and exhaustive. Last little test we are going to do, I'm going to erase that file again. And I want just to show you that the syntax is obviously equivalent to that one. So I don't specify one, I just use a default, okay? So I erase the file, echo, there we go, 3, 4, 5. Let's see if we have 5 of them in echo.out. 1, 2, 3, 4, 5. Yes, it's working. Okay, so it's really easy to change a behavior here, to go from a redirection that's actually overwriting by default to a direction that's appending, to a redirection that's appending. Now, the bash shell offers you also an option to try to control that kind of behavior. So it's very easy to write, like when we get to writing scripts, you're going to see it's really easy to write a script that uses a tool and redirect the output to tool.out. And if we just assume that tool.out didn't exist. And if it exists, unfortunately, we lose all the data that was in there. So sometimes we would like to have a sort of safety in place that allows us to say, well, if I try to redirect, to do an overwrite redirection, but the file exists, I want you to stop. I want you to display an error message and do not let me proceed, so that I can catch up, catch all the occurrences of that kind of behavior in my scripts, in my programs, and correct it. Okay, because that's not what I want. I don't want to lose data. It's not normal. The file should not be there already. So there is a way to ask our bash shell to keep an eye out for this kind of stuff. It's going to be an option that we use. So set-o. Okay, the name of the option is no clubber. Once I set -o no clubber, I can use echo hello world again. Okay, I can try to redirect to echo.out, which exists. As you can see, I was able to complete it. And when I do so, it's going to tell me cannot overwrite existing file. So it didn't modify the echo.out. Okay, it still has 5 of our hello world. And to make sure that we distinguish, then I'm going to use hello world again, and you can see that yes, that was not put at the end of the file, that was not used to override the entire content of the file. If I disable this option, so I use set +o, +o no clubber, okay, then obviously if I try to do the same thing again here, and now I try to display my echo.out, you see it has been overwritten. Okay, so that no clubber option is a very easy way to set your shell in, let's call it paranoid mode, where it's going to keep an eye and make sure that you are not overwriting by mistake redirection files. Okay. Now there are some times where you want to be prudent, so you want to have this set-o no clubber. Okay, there we go. Set-o no clubber. So again, echo hello world, still in echo.out, you can see that it didn't modify echo.out. So I have my protection on. But sometimes I want to be prudent, but I need, at some point, when I am really sure of what I'm doing, I need to be able to specify that I want to overwrite this specific file. So here I cannot do that. I cannot overwrite the file by default, but there is a syntax which is using the pipe symbol. So this is the one that's located above backslash, above the enter key on mouse keyboard. So the pipe symbol, which we're going to talk about later, see how we use it to pipe information between processes. But here it's right after my redirection symbol, no space, okay? And it means pretty much I want to override the no clubber option if it's there. So I am sure I want to actually overwrite this file. So let's try it. You can see this time I didn't get that error message, okay? The shell knows that there's a file that exists, but let me overwrite it, sorry, because I had this override in place. Okay, I said I know what I'm doing. I really want to push this information right there. And obviously this is working with a redirection of standard output. It's working with redirection of standard error. So I'll let you, play with the standard error on your own. But this is going to be exactly the same ID. So we have added a little syntax here. We have added 2 levels of syntax. The first one was the base syntax that we studied already. Then we added this first level of syntax, which is how to make appends. And then we mentioned the set -o plus O no clubber option. Okay, to put the shell in this paranoid mode. And then we specify finally the option to override this option, the shell option, by saying I know exactly what I'm doing. So there's a new syntax. Okay, we use a pipe bar after the redirection symbol, and that means pretty much I know that there's a file there, and I know it's going to get overwritten. Ignore this. Don't warn me about this. I know exactly what I'm doing. Okay, and that concludes pretty much the use of simple redirection in overwrite mode, even if you have no clubber option set. So that's going to wrap up this video. Thank you for listening.